So now kind of getting into a little bit more of the, kind of advanced options that are available to you. And really the thing we're going to focus on is kind of the difference between list walkers and scanners, right? And if you notice and you were to go through the actual modules, you'll see like PS list and PS scan. You'll see connections and con scan, hive list, hive scan, things like that, right? And there's differences between those two that we're going to talk about. And they're important differences to kind of understand, because they're reporting data from two different vantage points, right? Do you have a question? No? Excited? Yeah. We'll also talk a little bit, kind of briefly, talking about kernel modules and loaded drivers, which, if you don't understand what kernel modules are and drivers are, it's just a mechanism. Really, this is kind of important because of the level that they run at. So kind of things that look suspicious are certainly more noteworthy because they are running with basically the highest level of privileges. We'll talk briefly about the SSDT, the System Service Dispatch Table, and we'll also talk about the new volatility plugins, which are designed to identify malware-specific artifacts. So the first thing, kind of talking about list walkers and scanners. Everyone's familiar with kind of putting it in disk terms, right? Because you're probably more familiar with disk analysis. Everyone is familiar with what the MFT is, right? Or the file allocation table, right? FAT table. Or inode entries in Linux and Unix. You understand kind of how that works, right? The operating system looks for an MFT entry. It says, OK, this is where that file starts, and then it goes to that file, right? There's an offset in the MFT that says this is where it begins. It's sector, cluster, whatever. Now, when you are performing analysis of your disk images, files don't always have MFT entries, right? You can have deleted files, right? You can have things that are in unallocated space, slack space, so on and so forth, right? And so how do you identify those files? How would you get, like if you had a deleted Word document, how would you get it? How would you get it so you could see it and view it? It's in unallocated space, but the whole document is there.
You got to find this file entry, and you have to find how long is that document, what does it say its length, and where's it sending?
But you don't have a file entry. You don't have anything associated with it. All you have is just it's in unallocated space.
File carving?
Doesn't in-case do it automatically?
It can, but that's if it has a file entry. It needs to be able to point to something.
Look for file set, headers and footers of the file, and
yeah, you'd carve, right? You're basically going to do a signature search for, like, can I find the Word document header? And then you're going to look for the Word document footer or whatever, right, to basically carve out that data. But you're doing a signature analysis for the headers associated with that file. So when you have, so list walkers really work like the file allocation table or the MFT, right? They look through and they say, this is where a process starts, and this is where I'm going to go and get information on it, right? Scanners do basically the carving or signature identification, where they say, I don't care what the kernel says the process listing should be and where it says things are. I'm just going to look for where process entries occur, right? So it's basically looking for a signature that's associated with a process entry, or with a connection entry, or with a registry hive entry, or so on and so forth, right? Their associated module. So this is a mechanism by which you can gain other information. And what's beneficial about scanners are that they'll get information about terminated processes, closed processes, hidden processes, right? That aren't showing up in the process list. So that's really where it becomes important. And so if you kind of think of it in those terms, you kind of think of list walkers as kind of walking through the file allocation table or the MFT. You think of scanners as kind of identifying by signatures. That's really the approach that those two modules are taking. But they're reporting the same type of information, just taking two different approaches. So here's some kind of examples: process list, process scan, hive list, and stuff like that. Files and file scan actually doesn't exist anymore. Only file scan does. But the mechanism by which it's using is the equivalent of files.
The scanning process will take a lot longer than the listing, I guess.
Not really. I mean, it's not that much longer. It is a little bit longer though, because of the mechanism that it's using. But fractions of time, right? It's really not significantly different.
Does it tell you which process already ended, which process still?
It'll tell you if there's an ended process and it finds an entry for it, yeah. So, kind of some of the things I want to point out is like if you have something that's like if you look at both the list and the scan, and something shows up in the scan but not in the list, that is definitely noteworthy. It can be a red flag. If it's a terminated process, maybe not so much. But if it's an active process that's running that doesn't show up in your PS list but shows up in your scan, that's something you should go, you know what, I may want to look at that more closely. It's important that this is important because you're doing another comparison. You're not relying on one data source. You're looking at multiple different data sources. Good malware wants to hide, so a discrepancy gives you another target to look for. So kind of looking at a little bit further, looking at drivers. Drivers are used by typically used by hardware on a system to interact with the operating system. And loaded drivers can pose a huge risk because they're basically running with the highest level of privileges, typically, as well as kernel drivers as well, which are modules because they're loaded directly into the kernel. So they have the highest vantage point, basically, for lack of a better term, where they can, because of where they're sitting, they have the ability to see things and modify or work with things that can misrepresent data to the end user. It's a common mechanism used by rootkits. So here's some kind of mechanisms by which you can go about identifying those as well. And again, even if you don't fully understand what kernel modules and drivers and how they work and how they go and stuff like that, don't worry about that. That's not really the point of this. The point is that if you find something that's a discrepancy, or you find something that's like, you know what, that path seems weird to me, or that, I remember seeing something similar to that by a similar name in something else that I did, let me go look at that more closely. It gives you another mechanism to kind of identify items of interest, I guess. The system service dispatch table, I'll kind of quickly talk about that. This is basically what the Windows operating system uses for its Windows API calls. So if you hook this, you're basically hooking the call that Windows is performing a function with. This is a common mechanism used by rootkits to hide themselves from being found or from a process to do something without its knowledge, I guess, is for lack of a better term. It's really just kind of a method of hooking those calls on the system. I also wanted to point out the malware-specific modules. The Malware Analyst Cookbook, which is a really good book if you're interested in doing malware analysis. There's also another one which just came out recently called Practical Malware Analysis, which was written by a couple of guys at Mandiant. Which is actually a really good book as well and has a lot of walkthroughs and stuff like that. But both books are really good. And this one in particular, Michael Hale Lee wrote a number of plugins that is now distributed with volatility. And they will specifically are meant to identify behavior associated with malware, which can be really useful if you're trying to kind of narrow your scope to certain areas. I also want to talk about kind of creating your own memory footprint. So this is kind of something where, in some cases, you don't have a memory image, but you want to see how an application actually interacts with memory. Virtual machines make this very helpful. Virtual machines are your friend. So it allows you to basically run an application, look at memory. You can actually load the vmem file. If you snapshot a machine, the vmem file can load directly into Volatility or Mandiant or whatever else. And then you can basically use that to see what the application is doing. You can change configurations with it, give it different options, give it different network connections associated with it or whatever, right? You can basically kind of work with the malware and see what it's doing inside of your virtual machine. It's important that you do this in a closed environment, not connected to the internet, everything else. I want to make that clear, right? Like, don't call out with the malware and stuff like that. But it's a way that you can kind of understand what the malware was doing and kind of perform memory analysis yourself and see how it would interact on like a victim machine or something like that. You can also use debuggers to actually walk through each individual instruction. That's beyond this class. If you're interested in learning more about this, I encourage you to take the CERT Malware Apprenticeship Program, which goes quite a bit into using OliDebug. But it basically, in this mechanism, you can walk through an application instruction by instruction. The benefit of this is that you can feed it data. Right? Like you can say, I want the command at this point to be whatever. You can modify commands in memory, and it'll walk through them, step by step. So it can be really, really helpful. So I just want to point that out quickly, that can be useful for better understanding an application, even when you don't have a memory image.